Hello, my name is Tom Walski. I'm a senior product manager with Bentley Systems, and I'm here to talk today about digital twins and how it's being used in the water industry. Over the last few years, if you're in the industry, if you've gone to any conferences, attended webinars, or did any reading of magazines, you've seen digital twins. There's a lot of information about digital twins out there, and there are also some misconceptions about it. So I'm going to spend my time today talking about some of the myths that have grown up around digital twins in the water industry. So what's a digital twin anyway? Well, digital twins have been widely used across a lot of industries, and the water industry is kind of late to get to the game of digital twins. So there are many other industries have them. Digital twins sound a lot like maybe a hydraulic model or a GIS, but they differ significantly from those technologies in that they not only look like the system, but they behave like it. And they're in a way that can be easily served up to many people. There's a lot of popular terms out there: digitalization, smart water, and Bentley's entry into the digital twins, iTwin. So there's a lot of things out there that refer to digital twins. So let's talk more about them and the misconceptions. I'm going to go through 5 of them for you folks today. Okay, number 1 is, oh, I must need a PhD in hydraulics to get into digital twins. It sounds like it's really powerful. It must be really hard. Well, on the contrary, digital twins are for everybody, from the CEO down to the maintenance crews, through the operators and the control room, to the engineers and planners. Digital twins are for everybody, and that's the beauty of them. You don't need a PhD in hydraulics to get to digital twins because they are basically made for everyone, a wide range of users all the way through the organization, which enables them to share data across a lot of different technologies. And that's one of the things that really is important about digital twins. If you think about it, there's a lot of digital technologies you have out there, from your GIS to your model to your SCADA system to work order management system. Now, you may not have all of these, right? It may not all be very sophisticated, but you have at least some of these different tools that build up to a digital twin. And that gives you the ability to solve a lot of problems. And a lot of these problems, you may not have known you can solve them, or you may not be aware that by linking some of these different technologies, you can solve problems you never thought you could in the past. Some of the things are network monitoring, keeping a track of anomalies in the system, pump performance, looking for places where you might be wasting energy with inefficient operation, tank performance. You're looking at the range of tank levels. Are you doing what you're supposed to be doing and turning over the water enough? Are we generating alerts and finding anomalies in our system? Are we keeping track of our water with our water audit? Can we respond to emergencies from pipe bursts, fire events, pump shutdowns? And can we do just real-time simulations in the system? Now, we can't go over all these in this presentation, but we want to get you started and we'll just get you to appreciate some of the technologies, and some of the mistakes can be made along the way. Okay, the second thing is, our SCADA system tells us what's going on in the system. So why do we need a digital twin? Well, SCADA looks at what's happening currently and what happened in the past. It looks at a limited number of locations where you actually have SCADA sensors out there, and it looks at only limited parameters. What meters or gauges do you have in the system? And SCADA, though, is very useful. That data is useful to complement what's going on in your hydraulic model, setting initial conditions for model runs, help in calibrating the model. So you put the SCADA system together with your hydraulic model, and you've got a very powerful tool. It can tell you what happens currently, what went on in the past, and the SCADA and model together can tell you what's going on in the future. It can give you any location, because the model can calculate the properties that you're looking at any place in the system, not just where you have sensors. And it can do any parameter. You want to know the velocity, you want to know the hydraulic grade line elevation. You usually don't get that kind of stuff in the SCADA system, but the model can use that information, solve the correct hydraulic equations, and give you that kind of information you'd like. And you can do things, like I said, not just looking at the SCADA and the model working together in the past, we call a hindcast, but at a certain time, the SCADA system stops. It just can't go with it. If you ask the SCADA system in the morning, what's going to happen at 3 in the afternoon, it's not going to know. It's not built to do that. But by combining the SCADA and the modeling, you can forecast into the future to see what's going to happen. Another one of these myths we come across is that, well, one person can just be the digital twin guy. He'll just sit in the corner in the office and do the digital twin. But that's not what digital twins are about. Digital twins are about sharing information. Now, you may have somebody who's the champion in the system, the person that really is enthusiastic and driving this, and that person needs the support of upper management all the way up to the general manager or CEO. But the real benefits is to get acceptance across the organization. because when you start building tools where you can share data across different technologies, it makes everybody's job easier. And it makes everybody more powerful, being able to do more things and get better insights. So the greater acceptance you get will lead to greater success. Now, this isn't going to happen all at once. It doesn't happen overnight. You just don't push a button on June 1st and all of a sudden you have a digital twin. It takes time, but not a lot, because you already have most of the components that you need right at your fingertips. You already probably have some kind of GIS or SCADA mapping. You already probably have a hydraulic model. You probably already have a work order management system. So all these things are most likely there. It's a matter of linking them together in interoperability and sharing that information. Okay, so what are some of the questions you might be able to answer when you share data? Well, the operator in the control room can see what the pump is doing in terms of flow and pressure, but doesn't usually have a continuous display of all the properties of the pump, such as the head, the efficiency, the power. But by combining the data that comes in from SCADA system with the power of the digital twins, you can see where the pump is operating. These blue points are where the pump is actually operating, and the curve is the curve on which the pump should be operating. And we say the black point is the best efficiency point. And we can see that in this system, we're not quite there. So now we have a clue that there's something going on in our system, and it alerts the people who are watching the digital twin and says, we've got to go out there and check that pump. Is there something mechanical wrong? Is there something wrong in the system? What's going on out there? Then the next myth is, well, we're really not ready to implement a digital twin. It looks pretty imposing, when really it isn't that bad. Now, because no system's ever perfectly ready. Every system has, well, we'd love to put some more SCADA sensors out there, maybe some new IoT devices, or gee, our GIS needs some more work. We can't be ready for this, but you've got to start. You have most of the individual components you need already existing. You don't need every component in order to create a digital twin. And it's an evolution. The digital twin takes a little bit of time, not a huge amount, but it takes a little bit of time to build the digital twin. But you need to take that first step. It's like someone who wants to become a great swimmer and an Olympic champion, and they have the right body type and all, and the right attitude, but they don't want to take that step into the water. Well, you've got to just, at one point, say, I'm ready to start the digital twin. You need to jump into the water and start swimming, and that's how you're going to become a champion. And as you have initial successes, these initial successes will lead to more successes. And people will notice, and they'll say, let's do some more with it. Let's just look at one other use case. We were responding to a pipe break. Now, when you get a pipe break call, a lot of times what you do is you send the crew out there with paper maps. But now, with the linking of the digital twin and the mapping and the GIS, you can say, okay, here's where the break is. Here's the valves you need to turn. And here's a list of people who are going to be either out of water or adversely affected by the pipe break. And this gives you a lot more capabilities with not a lot of extra work. Once you build that digital twin, this makes everybody's life easier because they know what's going on in the system. Now, I've mentioned modeling a lot as I've talked about digital twins. And we said, well, we don't have our model calibrated. We've built a model, but we're not sure how good it is. Okay, well, digital twin is more than just modeling now. It's not just a super powerful hydraulic model, but modeling is oftentimes a key component of it. And models can provide insight that you can't get from the other technologies. So digital twins help these technologies collaborate with the modeling effort. Now, they've got to bring the model and field data together. And this leads to model calibration, because what happens in calibrating a model is you're comparing what the model tells you with accurate field measurements. And when there's discrepancies, when they don't agree, you make the adjustments to the model or to the field data or to wherever the discrepancy is caused to make the model better. This will give you a better tool to sort your decisions. Now, one of the things that frustrates me is I'll go someplace and say, is your model calibrated? And I'm not sure what the answer should be, because people are expecting yes or no. The model is calibrated or it's not calibrated. And the real answer is it's kind of calibrated. No model is ever perfectly calibrated, but all models can give you some insights. There's a saying that all models are wrong, but some are useful anyway. And that's kind of what it is in our business. The better the job in calibration, the better you can use the model to help with decision support. And So when the model and the field data don't exactly agree, this is not a problem, but it's an opportunity to find out what's wrong. Why do these things not agree? And when you do this, you're going to find problems. You might find problems in your GIS, where it's connectivity, some pipes are wrong, or you might find a bad SCADA sensor. You might find an error in typing in some data in a hydraulic model. But when you find these things and correct them, that builds confidence in the model across not just the people who are doing the modeling, but the people in the operations and in other departments that rely on the model to support their decisions. For example, in this particular case, the place I worked where they had a pump station pumping through a meter out into the distribution system. And what happened was the model was saying they should be getting a lot more flow out of that pump station than they were. So we could have just said, oh, the model's wrong. But we went in there and said, well, what's going on? And it took a lot of extensive testing, and they found out that out of the three major pipelines that came out of this pump station, two of them had closed valves on them. Now, that wouldn't have jumped right out at you. People would have just been wasting energy pumping a lot of extra water through one pipe instead of the three, but you would have not noticed it. Which you combine the model and the SCADA data, which you did in your digital twin, you can spot these problems when they happen. So, some points to take away from this lecture are, digital twin is not a single thing. It's a toolbox. Some days you may not use all your tools, but they're there and available for you. And every water system is going to be unique. It's going to have different availability of data, different quality of the SCADA system or your GIS, but it's all going to work. You can make this work. And you want to focus on your pain points. Where are your problems? Is it water loss? Is it energy wasting? Where are our problems that we can attack with this? So thank you. That wraps up my presentation. Thank you for attending this session, and I hope that you'll be able to benefit from what I've just talked about.